All right, so you got it. Yeah, you got 10 seconds.
Your time is finished. Yes.
Thank you so much.
Yeah. Okay, but then is their questions.
Hi. How are you? Good. How are you? Fantastic. Great. Question about the use of chain functions. Can you just walk us through how you wrote the gallery script and what URL is hitting and stuff? Sure. So the idea behind the evaluator's script was that it would be an off-chain piece of data that be associated with the particular cargo credit to give it a risk evaluation. Whereas the off-chain data source, we didn't pick a particular one. This was more of a theoretical use case. But the idea was that this data would be brought on-chain, not through something like keepers periodically scheduled, but actually on demand, based on either the owner of the token or somebody who was using the token in a call. They had a public method to use the token and reevaluate.
Okay, question on the token transfer. Are you using ERC20s for token transfer? Are you using knowledge investing and using token transfer? What kind of?
So this is an ERC721 contract. So forward, we're using a traditional transfer.
Knowledge investing.
Yes.
One question. Since you didn't have time to walk us through the code, I'm looking at the repo. Can you just tell me what is the CCIP part all about, and what you're sending, what you're receiving?
Yeah, absolutely. The CCIP aspect of this project was that the NFT itself being transferred across chains. In of itself, it is its right. That'd be the idea.
Okay, so when you receive a CCIP message, you are calling the carbon NFT, and it's doing second. It's mint new NFT. That's it.
Yes.
Okay, cool. Thank you. Okay, I think we're done with the questions. Thank you, guys.
Thank you all very much.
Thank you. So, what typically the next? I think if you'd like to present the group, it's good. But if you use like 30 seconds to present your group and you have only 2 minutes, it will be too much. So be faster on this part to have more time to present your project now. So what's the next journey?
Next up, we have the A shield, and our tech is blockchain.
After the delay shield, Farcaster social whitelist, please come here to the right side, to the left side of the stage, please. Farcaster will be the next. And now we have a delay shield.
Hey everybody, I'm Trav, and this is Alex. That's enough about us. More about you. Probably everyone in this room at somebody has experienced the problem. You know, we all travel here, and there's probably been a time in your life where, because of flight delays, you've missed your flight or had a bad experience, right? This diagram kind of shows the current Web2 solution using an insurance broker. There's a partial solution, but we used Chainlink functions to create a better, more decentralized solution. And now Alex is going to walk through the demo.
Thank you, buddy. So, right today, not transparent and hybrid office. With delay show, for the traveler, you have fair price, it's easy to use, and it's quick to reproduce. And you have also the liquidity provider, which is like for them, you have a new opportunity of investment based out of real utility. So how this works is by a set of smart contracts that is connected to an API for getting data from flights, and we get this using Chainlink functions. So it's pretty cool. We made a 4-step script here to show this, and it's basically you do an agreement on the beginning. That is this function here. So you buy the insurance, and when you want to claim the insurance, then the smart contract is calling the API to get the data about the flight. So you know exactly how much time does this flight took, and I will show you the script right here. So this script is running off-chain by Chainlink functions, and you can see some parameters here. So, okay, is the flight insured? So, like the same code, is it in a valid period? That means like 1 day before the flight. And the last one is the
Okay, time is over.
Yeah, perfect.
Congrats to them. Students, 3 minutes. You can increase a bit the font. They can see nothing.
Hi guys. I just wanted to make sure that I understood the whole code base because we ran out of time. So for each flight before the flight, we'll just transfer some funds as an insurance, right? And how much in return will I get if I got delayed? Perfect. So the initial idea here is getting the double, getting like twice as twice the amount. But if we had more time, we were thinking to do something like where is it? So having a calculus like the extension of the trip in time times the length of the trip. Yeah. So that was like the next step, but for now it's like if you it's doing your perfect business. Okay, thank you guys. Hey guys, Google project. Curious, did you guys decide to have the functions code them on chain, or did you go with the approach? It looks like a passing functions code in from off chain each time it's verbaless. And why did you make this decision? Sorry, can you repeat? Yeah, your functions code. Did you decide to have that live on chain JavaScript, or are you guys like passing in each request from off chain? And what made you decide to do that approach? Because we can have all this data, getting this data off chain, like all of this data that is in an API, and you can do a lot of expensive computation also off chain. So it's good because then you have like more gas economy. I'm not sure if I understood your question. I was asking more around choice to either store your JavaScript code on chain or pass it with the functions request each time. The JavaScript code? Yeah, the functions code. Why you choose JavaScript? Sorry, I may not listen. Okay, we can chat about it. We can chat about it later. Okay, sorry about that. Okay, thank you guys. Okay, awesome. Thank you. Thank you. Okay, up next we have Forecaster. Up next is QLog. QLog, you're on deck.
Okay, guys, so James from Forum, other than that, lets you kind of manage any group that you're in from a group chat. I'm not going to talk about that, and to clarify, this project is not called Forecaster, just Forecaster. That name has been taken by the wonderful Forecaster Web3 Social. The concept of this sort of quick project was to allow creators who are on Forecaster to directly incentivize their followers, so they can make a class, say something like going to be minting an NFT on Polygon, react to this class, and then what we do is we use chaining functions to check that an individual has correctly liked or recasted that cast when they go to make that NFT. Okay, so the example here is so this web page. You can actually make the cast directly from here. This is just a cast from before, for this example. Sorry, this is weirdly scaled. So here you go, right? So this cast had 2 likes. It's from 11 hours ago because that's when I wrote this code. This is the one I picked. So it's got those 2 likes. You see that it's you. And then what you do is deploy this. Also weirdly scaled. To deploy this contract, so this is a modified 721 contract with Forecaster likes chainlink function as a kind of restriction on the whitelist commit. Basically, we have this Forecaster API called logic written onto this contract, and that is just a sort of flattened version of this basic function called Forecaster API from that contract. It's not too much else to say. Basically, it just runs, returns 1 because I have like the property, so basically I can mint and you'll just see that this transaction has gone through. This has gone through.
Just one request to the judges technically is if you can put your functions code in the repository with the rest of the code, so you can do it.
If I didn't push that, so.
Can you put it up on the screen right now, but please?
Functions. Yeah. Yes, this is a nice looking version of it, and then there's a flattened there's a flattened version of it, which is written off the contract. Okay. Just basically calls this. We just we filtered for whether or not there are verification. This demo is to like DWR because he's one that like the most, and then we just return 1 if that matches the ID.
So where are you actually returning the value in this? And where is the functions code returning the value? Because the complicated the
Oh, so this demo is being run from the example, the usage example.
okay, could you show me the line which actually returns the buffer, Node.js buffer object? Yeah, the input unit that's not a line. You see line 1 is commented out.
Yeah, that's what it says. This is just like the demo. So like the UI. That's what I said. So in future, like, it makes sense that they can actually do the class directly from here, and we pick that up in one flow. But it's just not separate. So this is the UI example. The contract is deployed, and then the function is deployed in the contract. It's kind of like a bit disjointed.
So is the function actually running?
This function did run yesterday. Yes, with like a basic version of it. And then it's just got this like stripped out version.
Okay, so right now in the repo, you're returning any value. Right now, the functions code at this moment does not return any value.
No. It's far from production ready. Don't put all your money onto this just yet.
Okay, thank you.
Okay.
Okay, up next we have QLog.ai. On deck is ZK CCIP. ZK CCIP, you're on deck. That's great. Hello everyone, and welcome to our presentation today. So my name is Joe, and this is Sharif. And we just designed this decentralized data set marketplace called QLog AI. So my question for you today is, who is better than you? That's right, 2 times you. If you can have this AI fine-tune the system with your own knowledge and experience next to you, how could that benefit you?
And the most important part is that you build up your data set, because the LLM models are like innovating crazy. Like in 3 months, there will be like a better one, installs the best one. So basically, what we built. Okay, I'm going through it really fast. So you have like a data set, you can add questions, you can download it so you can fine tune it. But we also have like the data market where you can get data sets from other people, which you can also use for fine tuning your models. So how do we build it?
So we built this full stack app. So the users from any chain or from any CCIP enabled EVM chain can interact with our CCIP interface that is using the contracts up here, and from there they can communicate cross-chain to our main implementation on Avalanche.
Yeah, that's where we use chaining functions. So basically, you pay link, and you pay link, and then we have like quite interesting thing, because we let the buyer also fund the subscription, so you don't have any maintenance. So, okay, QLog AI is online, so please check it out, and the code is also there. Thank you.
Hey
And
guys,
any VCs in the credits, our GMs are open.
how do you implement how do you implement the interfaces to make the user can actually get the response back from a different chain? How do you implement it into CCIP? Can you get some more details?
Sorry, what was the question?
So how did you use CCIP to get the response back on the initiating chain?
To see if the transaction went through to our main implementation.
Yeah, basically you are seeing the users on the chain A, right? And then it sends the request to another chain.
Yeah.
Does the user see the response back on the same chain, on the initiating chain?
Not with our current implementation, because we only got around to doing like a basic like token transfer. We didn't do the full like arbitrary messaging, which what we hope to achieve, which where you could directly call the intended methods over on the main implementation of Avalanche. So we didn't quite get to that part, but we did just get the basic token transfer working across from the other chains. So we didn't implement the response to that. Okay.
One question regarding the CCP. I'm looking at CCP repo, right? And then contracts center.server, right?
Yeah.
Okay, thank you.
What was the hardest part about using chaining functions for you guys?
Sorry, one more time.
What was the hardest part about implementing or using chaining functions? What was the hardest thing to do?
Okay, let's get it technical. You switched to the DR runtime, so I struggled a bit with that because it changes like the authorization header from uppercase first letter to lowercase, and I need to catch those rows at 4 o'clock in the night. So that's always wrong.
Sorry about that.
No, it's all right. Because what I do like is the 900 ms timeout, because the previous hack moment was like three seconds, which is really short, so that was 3 times longer. And the cool thing is we can now easily store the data set decentralized, and we have like 45 seconds, because if you look at the code, we have a retry mechanism, which gives us a lot of time, unfortunately.
Yeah, love that. Thank you.
Thank you.
Okay, thank you. Thank you, guys.
CKCCIP, Crossdown is next. Crossdown, come on up, you are next.
So, how is everybody doing? Let me start with thank you for this great opportunity. We had a lot of fun yesterday. My name is Lucas Ige, Super Brain. We are presenting the thing we call CKCCIP today. The reason why we approached this way, we face the same issue every day, and this issue is interactions with the field can be expensive. You know it, I know it. I'm the guy on the stage, I can see all your faces. You all experience the same thing. Gas fees can be extremely high. But we found a way by using CK, zero knowledge proofs, and the CCIP, the great thing that Jenny invented to reduce that problem. So in our case, it's especially expensive to do zero knowledge proofs because zero knowledge proofs are very computation intensive. It's very expensive to perform a zero knowledge proof, especially on Ethereum. So the solution we propose, to the point, is what we call the CKCCIP. I'm very sorry for changing the logo. I hope it's okay. The result that we're presenting today is inexpensive or less expensive CK proofs on Ethereum thanks to the CCIP. And we did that. We showcase one use case today with using Avalanche. We sent the intensive computation stuff to Avalanche, execute the computation on Avalanche, use the CCIP, send it back to Ethereum. And by doing so, it's still cheaper than using Ethereum itself. Right now, and as we have to bear in mind that we are in the midst of a bear market, we still achieve 70 cents of cost savings. You can imagine if you go down the road to 2024, 2025, when block space becomes more expensive, when Ethereum is more congested, these cost savings that we identified will increase significantly.
Because we're out of time. We're out for questions.
Perfect.
Hey guys.
So to show the code,
Yeah, I'm just looking at the code, proof receiver fusion, so is that the receiver contract?
sorry, can you just make it more?
Yeah, sure.
My screen.
Could you increase the font, please?
I think it's okay. We don't have to, I can just ask the question. It's actually,
Yeah.
what I wanted to know is that, are you calling CCNP send within the receiver, or are you doing completely different CCNP send back from the destination? And yeah,
We are just sending the approved data from Ethereum to the CCNP router. And then after 15 minutes, when the transaction is finalized on Ethereum, then the proof is verified. And the proof is verified in Avalanche. And we deploy the verifying contract on Avalanche, and then we are verifying it there, and then we are sending the result back to Ethereum with CCNP again.
right.
So,
So when you send it back to
Yes.
Ethereum, are you doing it within the CCNP receiver on the species side, or is it just completely isolated transaction?
We are doing it like we are sending the message with pay message with link from Ethereum, and then we receive it, and then in the receiving function we are sending with link again from in Avalanche.
Really cool, interesting use case there. Just out of curiosity, how you said it's about 15 minutes or something. To do the proof on Ethereum itself and pay the extra fee, how long will the user be waiting for that?
So yeah, we tested it and we found out that we are waiting for 22 minutes. But on Ethereum, I mean, we just paid like for $1 more, and then we can like wait 15 seconds.
Yeah.
But it's still like it's not still finalized on Ethereum.
Yes.
So
Correct.
it's like 7 minutes more. You need to wait 7 minutes more. Plus you pay $1 less, so the user can decide if it is worth it or not.
Yeah, awesome. Thank you. Any other questions? All right, thank you. Thank you.
Next up is Polestar, and next is cross-chain ERC20 permits. Cross-chain ERC20 permit is next up.
Okay, we'll say something that I'm going to quickly define the problem that we're solving. So at the minute, there is a lot of friction with participating with governance proposals on various chains without bridging, right? And we all know that bridging is expensive, it's annoying, you inevitably leave dust everywhere you go. So not only do we think that this solution will save money, but it will improve voter turnout. And now we're going to show you the front end that we've built for this.
Sorry about that. All right, so this is the interface of our cross-DAO platform. Essentially, the idea is that we have all these proposals, and these are proposals are created on every chain. So essentially, if I'm a Polygon user in this case, I can see proposals from Fuji and other like compatible chains, and I can also interact with them. In this case, as I said, I'm on Polygon, and I can pretty much come here and interact with the proposal that it's on Fuji and even vote on it. In this case, I'll just set up the transaction, I'll confirm it, yeah, I get back to the app,
and we will see also that the vote will go through. So in this case, I voted for the transaction, and then we can see also that we have a counter here, like that counts the amount of votes that are done on the base chain, and also the amount of votes that are done on other chains that will then be settled on the proposal when the proposal finishes. So now for the lecture, I'll pass it to Mika.
So let me give you a brief overview about our protocol. So there is a create proposal, so user will create a proposal, and then the proposal will be created on the source chain. In this case, the source chain is the chain 1. So base proposal will be created there, and then events will be emitted using CCIP to all the other chains. So the proposal, a cross-chain proposal object will be created on all the other supported chains. Then users will be able to vote on any of these 3 chains, chain 1, chain 2, or chain 3. After the voting period is ended, there is a chain link automation bot that is running every 30 minutes. So it will check if the proposals are expired or not. If they are expired, they will just close the proposal, and it will emit an event using chain links CCIP to all the other supported chains that return the vote counts from your chains to the source chain. And then those chains will emit another votes event, which will send the vote counts back to the source chain. And then the source chain will sum up all of these votes and check if the consensus is reached or not. If the consensus is reached, then the proposal will be executed as it will be dropped.
Okay.
Time is open.
Thank you.
Hey, guys, question. So up here the GitHub link, I see the governance.soul. Is everything that you described part of that?
Yeah.
That's
Yes.
including the setting up of the government contract as well as the election from.
So the setting of the government contract is in some scripts. In the smart contract folder /scripts, there are a few scripts to set up the governance contract, and also there is a setup script setup.sh in the base folder. Yeah, so those are the setup files.
And then is the automation as part of this entire GitHub, or you set it up through the UI?
The UI is in a separate GitHub repository under the same organization. The automation? Yeah, it is set up through the dashboard.
Sorry, with your chart that you showed, you have the votes go back to the CCIP, but they vote initially like through the UI, or do they stay on their chain? And I was confused. Like, so the summing up the votes part.
Yeah, so essentially when the proposal is created and synced to all the chains, each chain will keep the state of the votes across all the chains. And then when the time is set for that proposal, it's when everything is consolidated on the base chain of the proposal. And so the event is set.
So the base chain will sum up all of the proposals from all the different states and check if the consensus is reached based on the total number of votes.
Okay, what's the name of that function that goes out to the other chains?
Goes out to the other chains?
Yeah, to sum them up.
So it is like counts votes. Yeah.
Thank you.
So that's it.
On the automation part, when you kind of do that cleaning up exercise, are you running it automation jobs separate per chain, or are you running on one chain and then that propagates with CCRP to do the cleanup on the other chains?
So we are running automation on all the separate chains.
Yep.
One automation per chain.
Yep. Okay. Great for questions. All right. Thanks, guys.
Thank you.
Okay, next we have cross-chain ERC20 permit. On deck is Ledger Link. Ledger Link is next.
So, this is a cross-chain ARC-Pin permit project, which aims at connecting worlds one token at a time. So, the idea. The project aims to address the challenges associated with token transactions for different blockchains, focusing on simplicity and interoperability. And what it does basically is building on the AIP 2612 and CCIP chain proposals, which seeks to improve the way users manage and transact with their digital tokens. So it basically works as an integration with 2612 using the CCIP, and to take the functionality of 2612 one step further, allowing users to improve token transfers on different blockchains, but in one single transactions, which will facilitate token management in multi-blockchain environments. So this gives the user an enhanced interoperability of multiple tokens. And the project will enable users, as you can read, to transfer the tokens more easily and efficiently, and have the token balances in one single place using CCIP from Chainlink. So basically, it sends the approval from the Avalanche switching network to the token in the Ethereum Symbolic network, and creates one token out of different tokens. So you can check it on GitHub, and recently based the main programmer and I'm the contributor. Thank you. Questions?
Hey guys, question on the CCIP part, is that specifically to send the approvals only? I mean, if I understood right, it's more approving for a set of tokens, not token transfer itself, correct? That's
permit expansion permit permit extension and permit signing same every token you can sign all the tokens at once, right? Preference token transparency execution.
okay. Does the approval depend on which tokens are actually transferable by CCIP? Meaning, do you only send the approval for those tokens that are enabled within CCIP or token transfer, or do you send the approval regardless?
Sí, individually, so one, because the same for token, they have the permit enabled. Does that answer the question? Because I don't know.
Yeah, partially.
Partially.
Is a token on the source chain going to be merged, or you just cross this token to the destination chain, or you just transfer that permit?
Sorry, the last part.
I mean, you want to cross that token from the switching to another chain, right? And the token after cross chain, is the token burned on the source chain?
I learned this tokens, but it's the first person. The tokens exist in the processing, send the tokens the divided tokens on the same direction in every blockchain.
Okay, so no, thank you.
Thank you.
Next one, we have lecture length. Following them is pancake federated learning. You're on deck, pancake federated learning.
Hi everyone, my name is Arthur, this is Marvin, and we are jumping straight into the demo because we don't have that much time, so.
So the problem we're trying to solve is that most of the time developers have to deploy their smart contracts and build their smart contracts for multiple different blockchains. So what we've built is a way to deploy a cross-chain smart contract. So I'll show you how it works. Here I have a basic smart contract for saving pseudo-random numbers in the list. You can enter it here. And we choose a primary chain. So this is the chain that we want to deploy our smart contract to. And then when I click deploy, it will hit an API endpoint I created. It will take all of the public functions from our smart contract, and it will deploy these on all of the chains we've selected. So Polygon and Buy and Arbitrary Curly. That's how it works. And that way we can interact with our smart contract on different chains as we would on the primary train. So this will deploy. I set some up so you can see this. It takes a little while to deploy. So this is our main contract, and the API endpoint will get the public functions, and it will basically route your transaction using CCIP to this smart contract. So it's still deploying. So I'll show you how this works. We can connect here. Here we are. So we've deployed our contracts on Sepolia and Mumbai, and then we can interact with these. So I can pull this from Mumbai, and it will hit the smart contracts on Sepolia.
Time's up. Thank you. Ready for questions?
A couple of questions. I saw something called singular on your UI. I saw something called singular and replicated on your UI. Singular and replicated singular.
So there's also another way you can deploy cross-chain smart contracts. That's instead of it replicating all of your public functions, it has a smart contract which is one function, and it proves. So you pass in an encoded function signature, and it will send this through CCIP and call that function on the primary chain.
Okay, so instead of employing, it just calls that one particular function.
So the singular function smart contract will be deployed to all the chains, and you just send it the function that you would like to transact with, and it will route to a CCIP to the primary chain.
Okay, got it. I have another question. Can you also specify the address of the destination that you want to deploy to? So let's say if you don't have the same contract address on multiple chains, can you specify the address that you want on the destination?
Currently not, but you could pre-compute the addresses. I think using create opcode and do something like that.
Yeah. And then what be the deployer, like who would be the deployer shown on the destination when you do using cross-chain?
It will be your address. So
The wallet,
deploying at all chains. Yeah.
so the wallet address for
Yes.
Yeah, really interesting use case and kind of functionality there. Can you give us an example of what do you think developers want to use something like this for, like using maybe for NFT contracts and things like that? What's an example of an implementation of this that devs find that useful for?
I think minting NFTs on one chain from multiple other chains is a nice use case. Also, maybe entering decentralized raffles on one chain from other chains. Yeah.
Yeah. All right, awesome, love it. Okay. Awesome. Thank you.
Now you have Kakake federated learning. Up next is decent port. Decent port, you're next.
Let's go.
Okay, but we had until yesterday a federated learning environment to train machine learning models. And what we have done these 2 days is to put a blockchain layer here. What we have is 2 pipelines, the upload pipeline and the inference pipeline. Let's talk about the important one, that is the inference one. An actor user can access with the front end and buy a wallet to infer with that. And this amount of token is going to be deposited in Node Manager, that is a contract where you can deposit and transfer tokens. After the inference, this smart contract is going to pay to the trainers. And it's going to pay with the store contribution, it's going to pay tokens in function of the contribution.
And under the node manager, we have the CCIP of Chainlink to do the cross-chain interoperability. So what we do here is we are, for example, in Polygon, and we send tokens to the wallet that is, for example, in Polygon in the Avalanche testnet. And now we are doing the demo of the inference.
Here we have the contribution, the payments, and here the transaction. And if we go to here, this is executed like 0.65. We can go to the backend 0.65, and the 3 transactions are going to be executed. And this is the front end, where you have here to upload the data, to do the prices of the model, but we roll on backend because we don't have enough time. Yeah, questions?
Hey guys, question. You mentioned the load manager and you also mentioned CCRP. But the way I understood you using CCRP is for the payment part of it, right? Not for the computation part of this. Is that correct?
Yes, it's for the payment part. We calculate the contribution of the trainer, say, and the nodes that trainer. And then we pay them, depending, for example, if they are on, like I said, on the Avalanche testnet, but we are on the Sequoia testnet, we use this chain
Thank you.
With CCIP, are you doing token transfers, which could be a development or lock-in testnet tokens, or are you sending a message to the payment on the other channel with arbitrary messaging?
Can you repeat, please?
With CCIP, are you using CCIP token transfers or arbitrary messaging? So when you do a cross-chain messaging?
Yeah, we use the token transfer.
Okay. Is it burn admin or lock admin token?
Yes. Well, it's first, we lock in the
Lock admin.
sender.
Yep.
Yeah, we lock, and in the receiver, we
Mint.
mint,
Yep.
and then we burn.
Yep.
This
Awesome. All right. Thank you.
You're welcome.
All right, that's a decent point you are up. Next up is Bitcoin monitoring protocol.
Just so my name is Timur.
Carol?
So what we made is a port management view. Each port is subdivided into separate platforms, which is when you interact with the user as ways to solve a trade. And the trade itself is varied all the time, so no one trade is the same using Chainlink VRF. And the ports themselves, they mimic real life locations.
So now we have a demo prepared for you. So first we connect the MetaMask wallet. And if we can initialize port to create a new smart contract for a port. This gets created. Take a while. Now we copy the port contract address and put it into the Chainlink VRF subscription. Just, yeah, we put it here. Get the consumer. Spin it up. So yeah, it has created. We can now, once it has been created, we can buy a new dockyard, and for that we can trade and for trade level.
So in the future, since we believe that it's important to use hackathons like these as a starting point for your project, not necessarily to make a lot of fun, but also to keep working on it and to seek advice. So in the future, what we plan on doing is using Chainlink functions to implement the open weather API, such that trade itself is dynamic, and then you can use real-time data to affect the rewards and the time that a certain trade may take.
Yep, time's up. Thank you. It's awesome. Can you just go through what exactly VRF is randomizing with the use of VRF? Is it so when we execute a trade function, when the port trades with another port, we set the reward to be randomized using Chainlink VRF. Okay, so it's the reward amount that's random.
So the timer might be reward. So so we change it like it's either the money is random, so it's out of 100. So yeah, so it can be like 20, it can be 10, it can be 100. Okay, yeah, it's using chain reaction. Also. Awesome. Thank you. Thank you.
Okay. Next up we have a lottery protocol. Following that is adjacent finance. Adjacent finance, you are next. Come on up front.
Hello. Hello everyone, my name is Rahul Ryan, this is my colleague Davian, and we represent the Bitcoin Lottery Protocol. Our mission as a company is to offer a lottery marketplace with frictionless experience and integration to all major blockchain protocols. Lottery is a very fun game, and in our opinion, we can manage to reach everyone in order to participate in raffle games, duels, lottos, tournaments, customs, and guaranteed prizes. We offer a variation of games. Our focus is to create volume and frequency into the lottery games. We just managed to launch our first MVP, which is called the Rush Raffle game, and we advise you guys to check it out on our website. Yeah, the future of us are the Bitcoin Lottery Protocol is a fully customizable platform generator. It's programmable for lotteries, raffle contests, giveaways, distributions, and events.
We integrated CCI, and we basically can now bridge all the chains into one. So you can basically join a different chain from chain B or chain A. So let's say chain A is Polygon. All the other chains go with CCIP the tokens on Mumbai. Yeah, that's a great okay. So with what we actually did is initially we just implemented the CCIP. We had most of the logic previously for the VRF. We have a lot of cool optimizations like data backing and all kinds of cool features. So with CCIP, we can finally build interoperable raffles. All right, questions?
So just to clarify, you all had some of this project before, but here you added the CCIP part. Okay.
Yeah, so when users deposit tokens on different chains, does it get moved to a particular common pool or does it stay on that chain?
So if you mean you're trading the game from chain B to chain A, yeah, they just transfer the tokens and the data and then buys the tickets for the year. And then later on, if the draw happens, if they speak from chain B and they want to chain B, they will transfer the tokens like to chain B, or if they're in chain A, they'll get the tokens out from chain A.
Do the users get to choose what they want to get paid back with?
Great question, currently no.
Sorry?
Currently no. It's a great question.
Is it, so right now the default is that whichever token they deposited with, that's the token.
Yeah, so wherever the winner is, he will receive the tokens on any chain that you provide us.
So just to clarify, the VRF part was already existing beforehand, and you added the CCIP to basically make this multi-chain or cross-chain.
Yeah, and automation as well.
And automation. So what does automation do as part of the solution?
Automation here, basically, when you deploy the raffle, it's immutable, so you cannot tamper with it afterwards. Meaning, when, like in this game, this is just one of the games. Like we have stripped down to make it simpler. Yeah, but we have like a constructor over which we have like all kinds of checks for all kinds of different settings for different games. And the VRF right there is basically just checking if, like, let's you set it to 2 players, and when 2 players joined, the round is full. And if you want to buy tickets, you will end up buying tickets in future rounds.
Okay.
So you only get 1 ticket per round.
Yeah. Okay. And is the automation trigger for that based on time? Does the check to do something every set amount of time, or is it based on some custom logic?
No, it's just if the total events equals max players in the series.
Okay, so custom logic. Awesome. Thank you.
Thank you. All right, now we have adjacent finance, and up next is Temple. Temple, you're on deck.
Hi everyone. So today we're going to present you adjacent finance, which is basically a cross links and liquidity aggregator as CCIP powered. So all of us know more than today that there is more than 1,000 blockchain ecosystem that coexist all in isolation. And I mean the number of layer 1s, layer 2 keeps on growing, and there is a crazy number of dApps and all these composability features that exist, but with this isolation. So what does it lead to? It leads to fragmentation, like fragmented liquidity across different ecosystems. The only solution right now is kind of to bridge, but we all know bridging is really risky. Like we can think about the wall hack. It's very expensive when it comes to gas. Someone mentioned earlier, the Ethereum blockchain, the gas fees are really expensive and can be very slow. Additionally, there are missed opportunities on different chains and different ecosystems. So we want to introduce here adjacent finance, which is basically our DEX CCIP powered. What features does adjacent finance offer? We offer a more secure messaging protocol thanks to Chainlink CCIP messaging, which is one of the most secure, 10 years running with Chainlinks without any issues. We have an optimized gas spending on CCIP, which is one of the reasons why we use CCIP Chainlink. And we can, thanks to this messaging protocol, aggregate liquidity and kind of solve the fragmentation problem. And all of this with a seamless experience. So the ultimate question is, I want to swap my Shiba from AVAX to Matic on Polygon. So this is what the solution looks like. We have CCIP powered from chain X to chain Y, and using basically a router that we've implemented, we can swap chain to Matic. And basically we have Matic on the end. And this can be done on a peer-to-peer basis or just swapping when the liquidity is available using some price feed function of Oracle. All right, we're up for questions. Thank you.
Guys, since this uses like a text functionality on the destination, how do you account for slippage?
So forcing slippage is basically the fact that we have access to liquidity across different chains. We can guarantee the best price. So when the liquidity is available, we can guarantee the best price. And on another hand, if the liquidity is not available, we can have a change with the system or kind of a limit order price system, which basically like avoid all the fraud value and lower slippage because of all the functionalities across different chains.
Okay, so since you don't know what the slippage is going to be on the destination, how do you account for that on the source chain, like from a user experience perspective?
So we haven't had time to materialize this on the UI, but obviously it's something that should be taken into account and to give the option to the user to let him swap or not if like basically the slippage, the fees included is something that makes sense in this perspective.
Okay. And I was looking at your code and the example transaction. I saw that you transferred over BNM, right? CCM to BNM.
Absolutely.
What did you swap it with? I didn't see this one.
So this is just basically one of the transactions we have. So here we showed CCM Explorer where we made like a swap from Ethereum Symbiola to Polygon Mobile. And then here, basically using the router, we then did the swap from, if I'm not wrong, the Polygon Mobile.
Did you happen to swap it to a different token or after the transfer?
Sorry, no, we did. So it's just a transaction showing that the fund is correct. We could meet the sort of function.
Really cool use case. Love the cross-chain DeFi use cases. So given more time, the rest of the implementation would basically be to then do the swap for the token that was transferred on the destination chain, right? Yeah. Okay. On your slide, you mentioned something about a data feed. Did you use chaining data feeds in any way, or was that just to represent the price of the swap when you do it on the DEX?
No, I think that's like a future thing.
Yeah. Awesome.
Yeah,
thank you. Sorry, keep going.
Yeah, definitely that's for the future, but we just wanted to outline the fact that basically if there is no liquidity available, we could basically have a system, sort of limit order system where we basically post an order and refresh the order based on the Morocco price, waiting for someone to match it. Yeah.
Awesome. Thank you.
Thank you very much.
All right. Now we have a table, and up next, our last project, CCI Palm.
All right, cool. Hi, SmartCon and House. This is Hamish and Alex from Diffuser. We are in research and development, and we're here today to present Temple, which is a Web3 music analytics tracking platform. And we'll get to how that works now. First and foremost, we thought we'll go through what in the music industry this product is supposed to fix.
So the short version is no one monetizes via streaming. Spotify is looking to build a monopoly and obviously, which will give them pricing power for both producers and buyers of music. They also don't give you the data you need, they give you whatever they want. But blockchain is an open database. It's open for everybody. All the interaction with blockchain are also open. So let's build an open blockchain, cross-chain music data and data analytics platform. Can we go through to our technical architecture? Yep. So we have the isometer controller, which is our cross-chain class.
artist recording work, curator review, and recording group are all NFTs. So what we're doing here is, this is a music industry compliant data schema, meaning you have your NFT IDs, your primary index. You also have secondary indexes, which are your music identifiers, ISICs for recording, ISWCs for works, and IPIs for artists, but this is as well if you're multidisciplinary. Whenever anyone, we also incentivize interaction. So there's tokenomics by link. Whenever anyone interacts with this platform, they will be paying extra link, and that will filter up to artists or higher level curators. Most interesting level of tokenomics is eventually big players can invest right back into this platform, and then via better transactions, people can interact with this platform for free. So we can have the entire music industry supporting an open platform on Web3 analytics that will be self-sustaining, a real self-sustaining music data economy. And we also allow cross-chain transactions to occur. So you can write a review, you can create a work that's a derivative of another work, so you can track mixes and mashups. All through this, and it's all cross-chain. So you deploy on the ecosystem that you want, and this protocol will track everything. You index by the graph, you can index by your own indexer, you can index by Etherscan. I think that's it in short. What can we do with this?
We're out of time. Over to questions. Yeah, questions.
Could you elaborate a little bit about the cross-chain part and then find what is actually getting transferred?
Yeah, so we use the CCI ping general message instead of minting or blocking a or anything. And the messages that are getting transferred across are so if you're on a certain platform and you have your ecosystem of fans who follow you for your playlist, if you're releasing works, you can, as that reviewer, still interact with music on another chain, and then the review is still stored on that chain with that artist's music, and that's able to be transferred across chain and separated.
Yeah, so you have a chain ID. So for chains that are your own chain, it's just the ID of the review of the work. And then for things on other chains, you have mapping from a chain ID to whatever's going on that chain that you have access to your chain. If you're like any messages, so you don't have any data conflicts in terms of like NFTs in different chains. Thanks.
Thank you. All right, thank you. All right, guys, thank you.
All right. We have our last presentation of the day, CCI Calm.
Okay, time. Hello everyone. We are the CCI Calm team because, as everybody knows, the most important use case for blockchain is playing cross-chain Calm, right? But the CCI Calm is actually just a demo of an underlying technology that we think is extremely important for the growth of, let's say, CCIP, because what we're doing is enabling CCIP to be an any-to-any relay. So if you use CCIP, you know there are lanes, certain lanes connect certain blockchains, but not all blockchains are connected with lanes. So, for example, Avalanche and Optimism are not connected with a lane, right? And so if I want to do message passing from Avalanche to Optimism, it's not ideal. Why is this like this? Because, you know, it's expensive to, and it's an expensive process to maintain lanes, and so we came up with the concept of virtual CCIP lanes. A virtual CCIP lane is a lane that uses our relayer to relay messages from one blockchain to the other, even though they are not connected with a traditional CCIP lane.
So we can get much more lanes, right? Right now, it's 196 versus 44 if you use the CCI Pong, or if you don't use it, it's 44. But as the number of blockchains grows, the complexity grows, and the benefit of this system becomes even bigger. So it's a square, right? The more blockchains, the bigger the difference between normal lanes and virtual lanes from really long time. So what we do is we preserve security, we relay CCIP messages, we really don't introduce any additional complexity or any additional security flaws. We can have multiple strategies for relaying messages. You can optimize for speed or optimize for cost, depending on how you want to travel through the blockchains. And this is going to be, so this is our message that works. And this is going to be very, very useful for, like, let's say, bank chains, app chains. When the complexity grows, the usefulness of this system grows. And thanks for attention.
Hey guys, some question on use cases. So is this practice focused on messaging, like arbitrary messaging?
So yeah, this is basically for, we actually came up with this. We are working with CCIP in our company before the hackathon and everything, and this was a problem that we encountered, right? So we wanted to send messages from Avalanche to Optimism, and we couldn't do it. I mean, we could do it, but we had to write our own relay logic. So we thought it would be a cool thing to kind of abstract that away into a simple single-tone relay contract that any developer can just use and just not even think about whether a lane exists or doesn't, because the relayer, if there is a lane, the relayer will just use the normal lane. If there isn't a lane, the relayer will create the virtual lane and then use the virtual lane to proxy the message to the destination chain.
Got it. And let's say I'm a user of Avalanche and I want to get to a lane that chain that's not connected. How are you tracking? So let's say I send 5 messages. How are you kind of making sure that all of them get
So this hackathon implementation doesn't do it. We do have a way to do it. So basically, our system that we are already building on Chainlink in this company that we do. So if I want to show it, so I'm going to keep it anonymous. So we basically assign message IDs to every message, and then you can basically put requirements for sequential execution, or maybe you can just put them as independent messages, which don't really require execution on the other chain. So we also do some other things like relaying back to the source chain whether the transaction on the destination chain was successful or not. So this basic relayer, not connected lanes, is just one part of a broader toolbox. So you know, it's a complex answer depending on the use case. Yeah.
Yeah, cool use case. And just to clarify, in a traditional scenario, if you wanted to go from Avalanche to Optimism, you'd have to manually deploy contracts on Spolia to handle that kind of 2-step process. Yes, with this solution, I can just have a CCIP send on Avalanche with the right parameters, with the right feeds, etc. I can call that function, and then the Optimism contract will get called without me ever having to interact with Ethereum.
Yeah, so it will go through Ethereum.
I don't see it.
Have nothing to do with it.
Okay, so it abstracts away the multiple process.
Exactly. You pay fees only on the source chain, and you sign one transaction, and that's it.
Yeah. Last question. On one of the slides you talked about if you choose between prioritizing speed versus security or something. Can you explain?
Yeah. So if you were to optimize for speed, you would probably go through a single hop, right? But maybe that single hop goes through Ethereum, and then the transaction itself is expensive. But if you would prioritize cost, maybe it will take you 2 hops or something, but you would go through, let's say, some very cheap optimistic rollups for some other kind of thing. So it would be like a strategy, whether you would like to optimize for cost or for speed. Yeah. But currently, everything's a one hop because the amount of chains is still low enough.
Yeah, another question. So let's say I'm sending a message with 500K gas limit. Does your contract automatically pick up that data from the incoming message from, let's say, Avalanche, and then set the gas limit dynamically, or how do you?
Okay.
Yeah, I'll jump in. So right now, how you use the system is you have to encode, like you use chain selectors, and you have to encode this chain selector inside your EVM message you're sending. So you would literally say, okay, that's the destination chain. I want this message to end up on. And now our system, our relayers handle the rest. So they abstract away this complexity, and then they wrap this inside of multiple hops in order to reach the destination chain which you want it to be. We also do this in a secure way so that you cannot like fake these messages. So you need to, like these relayers, they are secure in a way that they can only broadcast the messages coming from an official channel and say it like that. So
for the gas itself, you still encode it in the original message, right? Well, the message that you want on the destination chain, you just call it on the source, and the relayer just relays everything, all the data.
Yeah, that's it. Thank you.
Thank you.
Amazing projects. Did you like the projects? Maybe before. Yes. We don't have like a break now, so stay here now because we are starting the closing ceremony. We know that the judges are like discussing and preparing, and they are telling us who will be the winners in a few minutes. But I'm starting the closing ceremony now with Kevin. One question. Did you like the chess, the game of chess? Yes? No, it seems not. Did you like the game chess? Yes. Would you like to have one of these in your home? Yes. What about if we ship this chair to your home? Yes. So we are doing a raffle with 4 chairs that will be shipped to your home. You don't have to make loss. Yes. If you are not, if you didn't win your chair now, after the pre-gaming, when the pre-gaming finished, you can get one, but it's by yourself, put in your head and go with your chair to your home, okay? But maybe you can get another that we are sending to you. Let's see. I will do this raffle now. I will deploy the content and do the raffle now. Before this, I need to pull up my computer 1 minute. Before this, I'd like to talk about the Developer Expense Program and also the Chain Advocates. We have 2 programs. The Community Advocates are for the people that are not developers, but you are around Chainlink, you really enjoy to learn, to be in touch with Chainlink, so you can be part of the Community Advocate program. What do? You help us organizing Twitter spaces, events, and be with us in the places. We have the other program that is the Developer Expense Program. This is for developers that also enjoy Chainlink and learn and study and deploy things using Chainlink. And if you'd like to participate in this program, you can have access, early access to our products. You need to sign the NDA because it's early access, but you can have this. And also, you can participate in a program where you can be certified to teach Chainlink. And we did the first wave of certifications and for one product, for CCIP. And because we know that at least 2 developer experts are here, we keep a prize to them to deliver here now. So I'd like to ask you to come to the stage, Ameshi and Gilbert. Where are you? Congrats, Ameshi and Gilbert. he used to help me in Latin. He's from Chile, so we did a lot of events in Hablando Espanhol, Hablando Espanhol, Spanish, together. Here is Amesh. He's from England, and he also helped me a lot in a boot camp that I did in Cambridge. And you are winning now your belt because they are certified in CCAP. So open your belt, please. Can you show them what you are learning now? What you are winning now? What is this? Okay. Okay. This is your yellow belt. You are this is what you wear your belt. So that's what you're doing here. Yes. And these guys will all in smartphone use wearing their belts. And if you need some help related to CCAP, some question, they can help you in smartphone. So congrats and a round of applause to them. Yes, this is amazing. Wow, our judges are so fast. I already have the result, but I have other things to talk before. Sorry. Now it's time to do the share hackathon. Let's do it. Kevin sent it to me like half an hour ago, the list of all the people that checked in. So I'm doing this with the people that was here in some time. But you must be here now. If you are not here now, you are not winning the chess. So, yeah. And because of this, probably I must run more than one number. Let's see. But first of all, I need to deploy the content. So wait a minute. I think, could you bring for me a headset?
Can I get a show of hands who would be interested in the chair going over one? Pretty good. Pretty good. Too bad that doesn't affect the raffle, but you know, hopes out for everyone. They are really cool though, the chairs, I have to say.
I'm good now, yes. So let's go here. So I created this content a few minutes ago. This is our raffle. Okay, the raffle Hacker House 23. And I'm doing this on Sequoia now. These are the parameters for Sequoia. In fact, here I was saying that I'm getting 4 numbers, but I can get for one by one, depending. We are defining this now. Okay. And then we had 401 people that checked in. Okay. I have all these people here in this list. Because here the list I have the sorted by the date time that they did the registration. Okay, the register. And you can see that I'm starting on 23. Okay. So let's deploy the content. Let's see if I'm in Sequoia. I don't know. Yes, I am in Sequoia. And I already was testing like half an hour ago. We don't always have any. So to use VRF, I must have an account on VRF subscription. I have it here. So this is my subscription number that I'm using now. And I have the maximum 401 digits. Let's print the content now. Fill. Wait a bit. I will close this because it was the other that I used before. Let's wait, appear a new content here. Yep. Yes, it's here. So this is our effect. After creating the content itself, I must add this content in my account of VRF. So let's do this. Copy the address, go to the VRF description, add a console. This is my content. I just approve it from MetaMask. And in some minutes we will have this. Next step. This is the amount of numbers that I'd like to get now. So we have 4 chats. Kevin, would you like to do the 4 or 1 by 1? What would you like to do? 4. Okay. Let's start with 4. But remember, if that number is not here, sorry, are you getting more? 4. Let's see if the other transaction is confirmed. Yes. So I was waiting over that. Transact. Who has the drums now? Remember the smartphone last year? Who was in the smartphone last year? The drums. Yeah, amazing. This was my question when you say 4, so it's 4 now. Yeah, no problem. So I already added the numbers to the VRF network. Now we need to wait a bit, not so much. When the numbers is done, they will appear here in this list. One point that can happen, okay, when I do like a handful with 10 numbers, this happened a lot, but now that it's 400, maybe not. What happened? One number can be like raffled more than once. Yes. The original number now, no, because the original number is so huge, so crazy. But what I'm doing now, I'm dividing by 401 and get the rest. In this case, I would have the same number twice. What happened with this? If I have the same number twice, I create here a mapping for each number that was raffled, and then should be telling. I think I forgot to update this. Yes. In fact, I'm not using this, sorry. I started but didn't finish. The idea here is if it's not used, we are using that, but you can see here that I didn't update when I use it. I forgot. I was doing this last minute. But let's see. If some number appear twice, we get one. No problem. List numbers? Yes. These are the numbers. Oh, let's see who is this. 112. Let's go back here. This is the 112. Wait a minute. No, not this. Where is the here? Let's see who is this person. Oh, wait. Maybe I know I was not yet. Field. Let's try now. Iaroslavi Titachuki. Are you here, Iaroslav?
Yaroslav, if you're here, come down up front. Woo!
Are you here? Okay, we are waiting for you. Yes.
Yaroslav.
Yes, no. We are waiting. Let's see the next. If you know that Yaroslav are around, please tell him to come here now. The next is 371. Let's go again. Here, first of all, I'm mapping this. Not do something wrong. Yes. And the waste is guided. Jack B. Jack B. Where's Jack B? Are you here, Jack B?
Jack B. Jack, yeah.
Are you here? Same. If you find Jack B, call him. Let's try a moment. 178. Should I write the names? I think yes. And then it's something wrong. 178 is let's confirm. Yes, I got. Yes, let's put another yellow here. And what's the name? Oh, it's hard. Sivijay Kalis. Where is Sivijay Kalis? Are you here? Come on. Maybe I do another with the actors that present projects. Maybe. Let's see. 2 and 2. Let's see the other. 355. Yes, it's here. João Ferreira. I know this guy.
Joel.
He was here. Yes, because this guy was invited to cover the event to the Brazilian community. So he was here. What's fun?
Are we over 4?
Yes.
Sergej, Jack B, Joel, Yaroslav. No one? All right. Everyone in the audience a little bit happier. I see some smiles.
Yeah,
I got a check.
I got the names here. João is not João. Okay. Well, I got some more. Let's go.
Yeah, grab us some more.
So, you have a chance.
If you want to come down up front, hopefully we get at least one this time.
Yes, I got the order. No, doesn't matter now. Let's see what's happening. I facilitate my life. I'm waiting, so I can wait in ways of you better. Oh, it's a mess. Maybe it's done now. I don't know. Okay. Do you think this is done? Can I go over there? I don't know. I'm facilitating my life. Wait a minute. Could be better, so. Okay, almost done. Ah, I'm here. I just arrived from you. You just wanna check. Ah, yes, yes. You are right. I confuse you. Sorry. Could be you. Yeah, it's a shame. Okay. Let's see. Now, let's go to the mix. These numbers. Now I have 214. Let's see if I facilitate my life or not. Because now I can do this. Not yet. Let's do this in the right place. No. Okay, here. Second round. Let's use the other color now. Oh, come on. Yes. Who is this? Christian Jesus. Where is Christian?
Christian, are you here?
This is just painful.
Oh. I can't believe. Next, who is next? Let's see. Next is 207. 207, where are you? Here. Yes, let's put some color on you. And you are this. Vitória ou Viva Bela? Vitor.
Vitor.
Here today. No. He was a speaker yesterday. Next. 353. 353, almost here. David Ursoeguia. David, you Ursoeguia are here now. Oh, come on, guys.
David. It's David in the crowd.
109 and 109, I see. Here. I reach my mouse. I don't know what's going to be. Let's see. Halima.
Halima.
Are you walking?
Halima.
Halima, are you here?
Oh no.
No. What's the next? What's the next? I do the last time, okay? And then I'm thinking about me.
We have a winner.
Yes. Where is he?
Christian.
Hey, Christian. Yes. Yes. So last time I do 3 more, and then I'm doing the results, the actual results. One more time.
If anyone else is in the crowd and you're being shy, don't be. Come on down and claim your chair.
Maybe I asked someone to dance. Thanks for the chat. We have the numbers in 1 minute. And let's see what's happening here. We are here now. So let's talk about the beginner challenges. If you are, who was in the beginner room yesterday all day? Those are hands. Yes. it was really amazing because I know that we have a lot of people that starting from zero and they stayed until 11 p.m. Learned all the services. If you didn't get your swag with me yet, when I jump off, you can go over there with me, okay? And they did all of these exercises, all of these challenges, and at the end, they filled a form with all of them. If you are curious, you can see what they did yesterday, okay? It's here. I think before that, remember I did one more, let's see. Okay, number 13. 13, where are you? Here. Let's put a new color on you. This. And Kubilai Ozexelik. Kubilai, are you here? Okay. After this one, okay. 312. Richard, tell these two have this. 300 is 2 or 5? 2. 312. Okay. Here. Let's see. Who is this guy? Corley Daniel Kaplan. Is Corley Daniel Kaplan here? The last of this raffle, 147. Yeah, okay. So let's change the raffles and then we are doing in a different way. Is this? Let's see. Is this? Alexander Bujas. Are you here, Alexander Bujas?
Alexander, come on down.
Yes. Yes. Who's that guy over there? Yes. So we decided to go in this list, and if you see your name now, the first name that we found now it will be yours in this list. So let's put the names on screen again. I was trying to not show all the names, but it didn't help me. Who are you? 12, 6, 6, 90. What's the other? 4? You are 90. Is the first in this list. 4? 4. Okay. Constantinos and Mike, both of you on the chairs. Yes. Now we are ready to the prizes. Probably I need to refresh this. Is this? Okay. Okay. Are you ready? Are you curious? Really that I can go forward and share. So, if you are a winner now, at the end, we are contacting you. You have your email, so we can help you later to give your prize, okay? Let's go. Yes, we have more than 30K in prizes. This is amazing for our first webinar. And we are starting with CCAP channel. Let's see first who won the second and third place, like both are equal. And I don't remember the price. Let's see. No, I think he didn't like me. I didn't. Maybe yes. Okay. In this side. I will do the first here. So, we have Letter Link and CCI Pony. Yes, yes, 2,500. Let's see who won 5,000. No, I think this is like my computer. Cross down. Now, I didn't know that was a peer field, so well, going to be a field. So, changing functions. Insurance, I need this a lot. And the second place, Cargo Link and Farm Caster. Congrats to all of you. You did an amazing job. And you know that the hacker house itself, it was 30 hours. But to hack, you have 12 hours. Maybe this is 24, 26, because we start yesterday 10 a.m. and I give you 1 more hour for you, 2 hours. So you have 26 hours to hack. Bien. Vamos mirar ahora. Ahora, no lo sé cómo vas a pasar esto. No, parece que no. No. No, vamos a salir y volver. Sí. Bien. No. Sí. Gracias. So, automation, interface, 5,000 cross down. When I press the button, cross down where I am, yes, over there. Amazing. And 2,500 this support and Bitcoin ordering protocol. Where are you guys? Bitcoin over there. And this support here. So if it's not working with them, yes, the clip is working now. We are here. Yes. So congrats to all of you. I think really you create amazing projects in this time, and you know that the groups was small, so I know that you worked a lot. I saw some groups working hard all the night, and your work was really, really amazing. A round of applause of all of you first. Yes, our hackers. Let's go. I don't know what I need to do now. Oh, we're finishing. Yes. Oh, no. Would you like to have more time next year? Yes. Would you like to have it all weekend, start Friday into Sunday? Yes. Probably they think no. They think I'm crazy, but I'd like to have it. Yes. Yes. Yes, and I know that I think we did very well. I'm so proud of this, like in the way that I think the way that we did is amazing. But I always would like to do better. So I'm pretty sure that next year we are going to have more better hacking house for you guys. I'm here I learned so much. Harry, what do you think to talk stuff with this? And you guys too.
So thanks, Steve. Yeah, just want to say how proud I am of the hackers, especially the ones that were here. I was here until about 4 in the morning last night. There were quite a few hackers here still hacking our own projects, still coming up to us, asking, trying to grind through, get through some technical issues that they were having. They were still motivated, still keen to try and push forward with their projects. And yeah, that was amazing to see. I just want to encourage everyone to continue to participate in hackathons. You know, we talked about our training hackathon that's coming up. Go to hackathon.link and have a please sign up. Hackathons are not just for experienced developers, they're for new developers as well. It's very easy to team up with people, come up with some cool ideas, and as you can see, very easy to win some prize money as well. I just want to say thank you to everyone for joining our Hacker House, and hope everyone has an amazing smartphone.
So if you didn't register yet to the next Chainlink Hackathon, is here now, starting 8th of November, 5 weeks online. Ah, yes, we have cards to this as well. Just like perfect, amazing. But estamos en España, estamos en Barcelona, entonces, si quieres hacer tu registro del próximo hackathon en español, hágalo. Estamos acá para eso también, hablamos español también y podemos ayudarnos en español también. Entonces, puedes hacer tu registro en español, ¿sí? Muy bien. And as you can see around in the smartphone, in the conference itself, it was, I'd like to say thank you to all of our production team that was really, really amazing. To all the community advocates and developers, experts that they come here with me as well, and you helped us a lot. For the production team that we had, but also for all the Chainlink employees that was here all time working hard, working in crazy schedules, doing crazy things, and to be sure that we are distributing this way. Do you know that we mounted this chest? Yes. I was with Daisy Crew 2 days ago mounting this. Yes, this is really amazing. We made this. It's so crazy, so excited to see how this is now and what we built. Yes, thank you to everyone that was part of this. Thank you to every one of you that are here, that attend this. And remember that if you still would like to get a chair to your home, put here and go if you're checking, but only after the preview, not now. And someone yesterday asked me about the pillows. No, you cannot get the pillows.
Can I pay for it?
Exactly, this is your question. In the future, we are creating the Chainlink store and you can buy it, but not now. I'm sorry. But you can put this in the future if you want. So this is, thank you everyone and see you around.